When we turn our atmospheric monitor on, we're going to have LED lights on the top. Greens indicate normal operating sequence and safe operations. They'll blink or flash at a specific designated time every 15 to 30 seconds depending on the setup. Red LEDs will indicate alarming status. These are the sensor locations. Here's the scrolling buttons, and here's the power button. So in the mornings when we turn our monitor on, we'll have the indications, we should hear audibles and visuals, and then the monitor is going to run through a self-check. It's going to analyze the sensors, it's going to tell us what the low alarms are and what the high level alarms are. We should validate all those numbers to ensure that they're within the desired ranges that we want the monitor set up for. When the monitor is thinking or processing through systems, you'll typically get an hourglass or a time clock indicator to tell you that the monitor is in a working mode. The initial screen also tells you the pentane is the calibrating gas. There's our low air alarms, or our low alarms. There's our high alarms. Then we process to the short-term exposure limit levels and the time-weighted average levels. Then we see the primary screen. The time and date stamp on the monitor, ensure that those are correct, and then it'll tell us the last calibration date as well as the calibration due date. Once that process is done, you'll get an option to do a fresh air sampling. If you want to do fresh air samplings, then you acknowledge that. It samples the air immediately in this environment and it zeroes out the monitor. Remember not to do fresh air sampling tests if the monitor has any potential for exposures or hazardous components in the atmosphere. Once you're in sampling mode, you have scrolling buttons that will allow you to access other screens. The first screen we can access is the bump test screen. Remember that we want to perform our bump tests in the mornings, exposing the monitor to a specific concentration of sampled gas and ensure that the findings or the results are within the allowable limits. Scrolling to the next screen from bump test, we'll see that we have peaks and we have minimums. To zero out our peaks and our minimums, we simply hit the other menu button, which will clear out those components. Now, when we start talking about applications, we've already covered what we want to do in the mornings at shift change and during our inventory checks on our trucks. We now want to move into how we start deploying these when we get on scene. So when we arrive on scene, one of our first priorities is to ensure that this has already run through whatever test you're going to utilize, whether it's your bump test or your fresh air test, that it's in sampling mode and that it's ready to go. So that when we get off of the truck, we are already sampling the atmosphere. As we approach the confined space or the trench that potentially has a compromised atmosphere in it, we're monitoring our readings and we're making sure that we're evaluating and documenting immediately what those readings are. One of the imperative components of atmospheric monitoring is documentation. So you want to make sure that you keep a log of all of your readings and that all of your samples, which are done continuously, are being recorded on a 5 to 10 minute basis. It doesn't mean you always have to communicate those findings to command. It just means that you have to document them. Command can set up parameters for you as the atmospheric monitoring team in which they only want to be notified when you hit certain levels or are outside of certain ranges. So you've got your log going, you're monitoring, and as you're approaching, if you have any hits and you're getting any indications on your monitor of a compromised environment, make sure that you are communicating that to command so that they can start cross-referencing whatever that substance is or whatever that contaminant and hazard is with the NIOSH and ERG guide. There's a couple important things we want to focus on the NIOSH guide in particular. If we have time-weighted averages or short-term exposure limits and we're getting hits on those with our monitor, we want to make sure that we are referencing those in the NIOSH guide to understand how those are going to correlate to symptoms for our victims and for us as rescuers so that we can develop appropriate profiles for rescue versus recovery. Remember that this initial reading phase, while we're approaching the space, should be done with full respiratory and PPE protection. We want to assume that these spaces are completely compromised until we can absolutely verify that the area is clear and that it's tenable without those safeties in place. As we continue to close in on the space, we want to focus initially on a recon perspective. So we're going to utilize our monitors to sample the initial opening and whatever we can get to with our probe or by extending this directly into the space. Now, if we don't have a sampling probe to where we can administer the probe into depth or into distance, then what we're talking about is attaching the atmospheric monitor to a rope or to an extension pole, some type of long-handled tool, and advancing it into the space. As we advance it into the space, if the atmospheric monitor is already alarming outside of the space, then advancing it into the space is not going to tell us anything different. And as we pull it out, it's going to fall right back or revert right back to the readings in the atmospheric layer that it's in. So to determine what those levels potentially were at depth within the space, we have to access the peak modes on our monitor. All monitors should be equipped with the ability to scroll through screens so that you can see both minimums and peak readings based on that time period. Once you've evaluated what those peaks were, you should have another button selection that allows you to zero those peaks out. So document what your peak was at depth, record it, and ensure as you're advancing the monitor and withdrawing the monitor that you are doing it at a speed or a rate that's commensurate with the sampling time of the monitor. So you want to think about every layer of that monitor as atmospheric layers, 1 to 2 foot layers, and you're letting the atmospheric monitor stay in each one of those layers until it has time to process that atmospheric layer, then move it down to the next layer, let it have time to process, so on and so forth. That pretty much condenses or compresses and summarizes all of the basic concepts and the focal points of atmospheric monitoring for confined space and trench or excavation-based emergencies. Remember to refer to your manufacturer's guidelines, calibrate your monitors as the manufacturer recommends, make sure you're doing your bump tests in the morning, make sure you're doing your fresh air tests, sampling tests as needed, and make sure that you're really proficient in accessing all of the screens, understanding how to manipulate between peaks and minimums, and then access your primary screens again. Understand your conversion factors on your flammability chart based on your sampling gas. Try to develop a good working knowledge base of your monitor's capabilities and how to apply all that knowledge so that when you're in the field, you can make rapid decisions that will impact a viable outcome for your victims.